friends, welcome to another video of the lecture series Atomic Structure. In the previous video, we came across two different atomic models, their merits and their demerits, which led us to find a new theory, a new model, or at least a modified one. We finished the last video with the Rutherford's atomic model, which was in a way the foundation of modern physics era. In today's video, we are going to discuss the drawbacks or the demerits of the Rutherford's atomic model, and we will going to take an entry to the Bohr's atomic model. So let's get started. To know what the demerits of Rutherford's atomic model or to know Bohr's atomic model, we need to have a brief idea about some topics. Those are atomic spectra, electromagnetic radiation, and quantum theory of Max Planck. So let us start with atomic spectra. What is a spectra? A spectra is a band of colors. When a composite color goes to a certain process, the various components of it get separated. This phenomena was used by scientist Balmer in 1885. What he did was something like that. He took a gas discharge tube containing hydrogen atom. He then excited the hydrogen atom in some way. Then he took a very narrow slit right in front of the propagating direction of the beam, so that the beam became very narrow. After that, he placed a prism on the path of the beam. Now at this point we need to know that the beam is a composite light, and the job of the prism is to separate the various frequencies of that composite light. So after going through that prism, the different frequencies of the light get separated and falls upon a screen. Then he saw that he got 4 colors of discrete beam: red, bluish green, blue, and violet. After getting these separated lines of different color, he tried to give us a formula, an empirical formula, which will be able to predict the colors of the different frequencies of light coming out of the prism. And the formula was 1 by lambda is equals to 1 by 2 square minus 1 by n square into r, where lambda is the wavelength of the light, n is a natural number, 1, 2, 3 and so on, and r is the Rydberg constant, which has a value of 1.09 into 10 to the power minus 5 centimeter inverse. Now at this point we should know that Balmer did this experiment with equipments which was not so much sophisticated, and that's why he got only 4 colors of discrete lines, and those 4 colors were red, bluish green, blue and violet. But after him, few more scientists did the same experiment with much more sophisticated equipments, and they changed the equation of Balmer a little bit and succeed to make the hydrogen spectral series or the spectrum widen. Find the other discrete lines of the hydrogen spectral series. Balmer found only this part of the series, which is in the visible range, which we can see through our naked eyes. But he could not explore this part or this part of the series. So moving to the next topic, which is electromagnetic radiation. Now what is radiation? Radiation is just emitting of energy, and when an atom radiates energy, it is in the form of electromagnetic. So we are dealing with electromagnetic radiation in this lecture series. Electromagnetic radiation can propagate through empty space. In this lecture series, we don't have the scope to dive deep into the theory of electromagnetic radiation. We will just have a brief idea which will be needed to understand the basics of the atomic structure. Why the atom emits electromagnetic waves at all? The electromagnetic theory was first proposed by Sir James Clerk Maxwell, who was a Scottish mathematician. In his theory, he argued that any charged particle which is accelerating will emit electromagnetic wave, because the charged particle which is moving can be considered as a current. So a charged particle which is accelerating with time can be considered as a current which is changing with time. And a changing current means a changing electric field. And change in electric field produces change in magnetic field. So the phenomena of change in electric field and magnetic field propagates through the space, and this phenomena is known as electromagnetic wave. Now we are ready to understand what was the demerits of Rutherford's atomic model. According to the electromagnetic theory of Maxwell, if a charged particle is accelerating with time, then it will emit electromagnetic energy. According to the Rutherford's atomic model, the electron is revolving around the nucleus in circular orbits, and we know from classical mechanics that when a particle is revolving around a point, it is actually going to a curved path, and whenever a particle is going around a curved path, it has an acceleration. So the electrons in the Rutherford's atomic model must have acceleration, and so the electron must be radiating or emitting electromagnetic energy. But if the electrons are radiating electromagnetic energy, then the radius of the orbit must be shortened. And if the emission of electromagnetic wave from the electron continues, then the radius of the orbit must be gradually decreasing. So if Rutherford's atomic model wants to satisfy the Maxwell's theory of electromagnetic radiation, then it must follow a spiral path into the nucleus. But if the electron goes into the nucleus, then the atomic structure of the Rutherford's atomic model is not there anymore, and hence the atoms becomes unstable. But in reality, the atoms are stable. That means Rutherford's atomic model is either wrong or incomplete. Another demerit of the Rutherford's atomic model was that he did not keep the proper arrangement of electrons in the orbits. That is, whether an orbit will have one electron or more than one electron. He didn't say anything about it. So, in order to overcome these demerits, someone has to come with a new model or modify this atomic model to satisfy both Rutherford's atomic model and to satisfy the Maxwell's theory of equation, the Maxwell theory of electromagnetic radiation. And then Bohr came with the modification of Rutherford's atomic model. But before going to Bohr's atomic model, we need to have a brief idea of quantum theory. Old quantum theory, I would rather say. Now we need to know that quantum theory is not about a topic. It is not like electromagnetic radiation, which is a particular topic. Quantum theory is a different approach towards understanding the physics. But it's a different approach than classical theory to get the result. It was coined in 1901 by Max Planck. What was the necessity of this theory? This was the time when many an experiment was performed in which classical physics, or in other words Newtonian physics, was unable to explain the results, like black body radiation or photoelectric effect. At this point, we don't need to know about black body radiation. We need to have a brief idea of photoelectric effect. Photoelectric effect was a result of an experiment which was performed by Sir Albert Einstein. Now, what was the result of that particular experiment? In this experiment, Sir Albert Einstein found when a body is radiating or absorbing energy, It is exchanging energy in a discrete fashion or in chunks, but not in a continuous fashion. Later we will know this chunk of energy as photon. The energy associated with these photons were E is equals to h nu, where h is the Planck's constant and nu is the frequency of that particular photon. Now we are ready to go into the Bohr's atomic model. Now the Bohr's atomic model is nothing but a combination of Rutherford's atomic model and old quantum theory. It has three postulates. The first postulate states something like that: electrons cannot revolve around the nucleus in any arbitrary circular orbit, but they are allowed in circular orbits with certain radius, and these orbits are called stationary orbits. Now, what is the mathematical condition for the first postulate? The mathematical condition is the angular momentum of the electron revolving around the nucleus in nth orbit is mvr is equals to nh by 2 pi, where m is the mass of the electron, v is the linear velocity of the electron, r is the radius of that particular orbit, n is a natural number 1, 2, 3 and so on, which happens to be known as principal quantum number. H is Planck's constant. Sorry, the value of h written here is incomplete. It is actually 6.626 into 10 to the power minus 27 arc second. Now the second postulate, which states something like that: when revolving within these orbits, they do not absorb or radiate energy. The mathematical condition or the mathematical support for this postulate, the second postulate of Bohr atomic model, was not given by Bohr. He was unable to explain the reason of that particular postulate. It was explained in 1926 by de Broglie, and the third postulate is: if the electron travels from a higher energy orbit to a lower energy orbit, then it will emit energy, and if an electron in lower energy orbit travels to a higher energy orbit, then it will absorb energy. Now, it is considered that the energy of the electron is zero at infinity, and the closer it comes to the nucleus, its energy is getting decreased. The electron which is in the closest orbit in an atom is having the lowest energy, and the electron which is in the remotest orbit in an atom is having the highest energy. And so these orbits are known as energy levels. These orbits exchange electrons within them. They either emits energy or absorbs energy. So if an electron travels from a higher orbit to a lower orbit, it will emit electromagnetic radiation. So the amount of energy exchanged in this process is delta EMN is equals to EM minus EN is equals to H nu Mn, where En is the energy of the initial energy level and En is the energy of the final energy level, and nu Mn is the frequency of that emitted or absorbed energy. Now this equation was succeeded to explain the hydrogen spectra, which Rutherford failed to do, and this is the success of this Bohr's theory. Now at this point of time, a question may be arising in your mind, which is why we are experimenting only with hydrogen atom and not anything else. The reason behind it is hydrogen atom is the simplest among all the elements of all the atoms. It has only one proton in the nucleus and one electron revolving that nucleus. Now let us take a look at how the Bohr's atomic model satisfies the hydrogen spectrum or explains the hydrogen spectrum. Sorry, there is a mistake in these equations. All of this lambda should be replaced with 1 by lambda or lambda inverse. When the electron of hydrogen atom jumps from one energy level to another, it absorbs or radiates an electromagnetic wave of certain frequencies. Balmer took a tube of hydrogen atom. In that particular tube, hundreds of thousands of hydrogen atoms were there. And among those hydrogen atoms, in some cases the electrons were jumping from the third orbit to the second orbit. In some cases they were jumping from the fourth orbit to the second orbit. The opposite was also happening. That is, the electrons were jumping from a lower orbit to a higher orbit, and thus Balmer got those separated lines of different colors. And so the theory of the Bohr's atomic model was completely satisfying the hydrogen spectral series. Now you may already guess that what is the next thing I am going to mention, and that is the demerits of the Bohr's atomic model. But I can only say wait, because that is the topic of the next video. Thank you.